Here we're going to be looking at identifying the parts of a quadratic graph. A quadratic function contains an x squared term. All of our x squared terms are going to then create what we call a parabola. Parabolas are just basically a U shape, and they either point up or point down as there are functions. Identifying our parts of our parabola, there's a dashed line that goes through the center. This is what we call our axis of symmetry. And what the axis of symmetry does is it separates our parabola into two halves. And basically, if that's the line, if we fold it over on that one line, it'll be back on top of itself. This point right here, this is my y-intercept. The y-intercept is simply where our parabola crosses the y-axis. My point here at the bottom is my vertex. And in this case, this vertex creates a minimum because that's the lowest point that our parabola will go. Here, these 2 points, these are my x-intercepts. This is where my parabola crosses the x-axis. Now, parabolas don't always have to cross our x-axis, but when they do, they are our x-intercepts. They're also referred to as solutions. You'll also see them referred to as roots or zeros. These are all the same thing. Many ways of saying the same thing. Now, parabolas can also be going facing downward, and we label them the same way. Again, my axis of symmetry. This is what splits it in half. Here, this is my vertex. In this case, my vertex is a maximum. That's the highest point this parabola goes. Here are my x-intercepts. But remember, these are also referred to as solutions, roots, or zeros. Anytime you see any of those things in reference to a graph of this case, it is the x-intercepts. And then here, this is my y-intercept. Here we're going to be looking at the different types of solutions and the different types of things for our graph. We're looking at our first one here, the number of solutions. How many times does it cross my x-axis? Well, it crosses here and right here. So there are 2 solutions. Looking at the second graph, how many times is it? Oh, it only touches in one spot, so there is 1 solution. And looking at the third graph, there are 0 solutions because it does not cross the x-axis. And our first one right here, what are the solutions? Well, this first one here is x equals 1. And our second one would be x equals 5. That's the 2 points where our parabola crosses the x-axis. Now my vertex, the vertex, remember, is in this case, this point right here. And it's going to be located at 1, 2, 3. And the vertex is always an ordered pair of point. And then it's going to be going down to -4. And since this one is going upward, opening upward, it will have, this is a minimum point. Now my axis of symmetry is a line. My line, it is a vertical line, so therefore it's this line here going straight up and down. It is the same as the x value of my vertex, so x equals 3. My y-intercept is this point right up here, and it is a point, an ordered pair. The y-intercept is 0. Y-intercepts always have to have 0 as our x value, and then 5. Looking at the second graph, we know that there is one solution. That solution is x equals 1, 2, 3, 4. And my vertex is the same as my solution here, which would be 4, 0. Anytime that you have one solution, that will be the vertex, is the x-intercept. The y value will always be 0. In this case, this is a maximum. It is the highest point on our parabola. My axis of symmetry is this line right here, this dashed line, and it is the same as the x value of my vertex, so x equals 4 is the line. My y-intercept is this point right down here, which would be 0, -8. But our last one here says the number of solutions were 0, so therefore solutions, well, there are none, so we just write none. My vertex, I do have a vertex. My vertex is located right here at the point -2, +3. This is the lowest point on the graph, therefore that is a minimum. My axis of symmetry is this dashed line that I just drew in here. Remember, it is the same as the x value of our vertex, x equals -2. My y-intercept would be right here. It is an ordered pair of 0, 5. And there are all the different types and different ways we can look at our parabolas or our quadratic functions in graphing form. Good luck.